Hello dear students, I welcome all of you to this session of Determinant, and today we have to discuss on some more important topics of Determinant. Already in our previous classes we discussed about the concepts of Determinant with its properties and with its minor and covector and solution. Okay, today we have to discuss some more concepts of Determinant, that is I am going to write that one, okay? Solution of system of linear equations. Solution of system of linear equations in determinant method. Or you can say it is the crammers rule. Okay? So today it is our new concept that we are going to read the solution of system of linear equations by determinant method or by crammers rule. That is our topic of discussion. So dear students, let us begin with this concept, that what we mean by system of linear equations. So system of, linear equations. Now system of linear equations means if more than one number of equations are present simultaneously, it is given, that is called as system of linear equations. So we will go for, and you know about the solution. In our previous class we discussed about the solution. You know solution is of two types, and according to solution it is either considered as consistent or inconsistent. Yes or no? So all the things are going to be discussed today. So first of all we will go for, initially we will read about the solution of system of linear equations, then we will go for the consistent and inconsistent. Okay dear students, so let us begin it. First we will go for system of linear equations of two variables. So what do we mean by system of linear equations of two variables? Let us begin it with some discussion. Consider the linear equations are a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Okay. Now we have to solve these two equations, and solve means what? We have to find the value of x and we have to find the value of y. Okay. So how we can get the value of x and how we can get the value of y? By using this crammers rule. Okay, or we can say by determinant method. Dear students, now see carefully what we have to do to find the solution of these equations of containing two variables. Okay, so what we have to do then to get solutions, that is value of x and y. X and y. What you have to do? First you have to find the determinant d. Okay. So we can say by Cramer's rule, the procedure is the procedure as follows. So you see what we have to do. So to get solutions by Cramer's rule, which is called as determinant method. So what we have to do? Find D, or you can say del. And what is D or del? It is the determinant containing the coefficients of x and y, that is a1, b1, a2, b2, and it is equal to in value a1, b2 minus a2, b1. Okay, so we have to find D or del. Then we have to find out dx or del x. Okay, and it is the determinant containing, replacing the coefficients of x by the right side value in del. Okay, so it is in the form of c1, c2, b1, b2, and you can find the value also. So what is the value? It is c1, b2 minus b1, c2. Okay, that we have to write down. Next we have to find out dy or del y. Dear students, what is dy or del y? It is newly the form determinant. Okay, I am writing it here. It is, so again I am writing it for your information. It is the determinant like this. I am writing it here. Similarly, we have to find out what? We have to find out our dy. Find dy or del y, which is like, it contains a1, a2, and we have to replace the coefficients of y by the right side value, that is c1, c2, and it is in value a1, c2 minus a2, c1. Okay, dear students, so in this way we can find out the value of d, dx and dy. Then it says, the procedure says, the value of x equal to dx by d or del x by del. Okay, so what it gives, the result gives, it gives the result of, you see, it gives the result of, what we have to write? Dx means we have to write the value, it is your c1 b2 minus b1 c2 divided by your d, that is a1 b2 minus a2 b1, and we have to find the value of y, that is dy by d, or you can say, what is your dy? That is a1 c2 minus a2 c1 divided by the value a1 b2 minus a2 b1. Okay, dear students, so in this way, this is the value of x and this is the value of y, and we are using the Cramer's rule or the determinant value to get the solutions of x and y. Okay, so this is very easily we can find, we don't need any type of other methods, so it is very easy as per the Cramer's rule. That Cramer's rule is designed by the famous mathematician Gabriel Cramer. So according to his name, this is called as Cramer's rule, and sometimes it is also called as determinant method, where we have to use the procedure of determinant and easily we can find the solution of x and y, the variables, the solution of the variables generally x and y by this method. Okay, dear students, so what I hope you can understand this way to find the value of x and y. Look carefully, dear students. Okay, so here we discussed about the solution of linear equations of two variables. Now similarly we move to solution of linear equations by three variables, and then we will go for some examples to solve it. particular examples are there. First I am writing the general way of solution of getting the variables. Okay dear students, so what I hope you will understand this one. Now we will go for the solution of three variables. So I am cleaning this one now. So now we are moving to solution of linear equations of three variables. Okay, so how we can find the solution of linear equations by three variables? So what we have to do? Consider the system of linear equations as a1x plus b1y plus c1z equal to d1. Okay, let one of the equation, it is containing three variables. Okay, one is x, another is y, and another is z. Let the second one is a2x plus b2y plus c2z equal to d2. And let the third one is a3x plus b3y plus c3z equal to d3. So you see there are three simultaneous equations are there which are of linear type, and we have to find out the solution of those variables, that is the value of x, the value of y, and the value of z. Now what is the procedure involved in Crammers rule or by determinant? What is the procedure involved to find the solution? Okay, so according to Crammers rule, what we have to do? First find d. Okay, as we did in our two variables, similarly here we have to find out d. And what is d? In the similar fashion, it contains the coefficients of the three variables, that is x, y, z, that is a1, b1, c1, a2, b2, c2, then a3, b3, and c3. Okay, and what I hope you can evaluate and you can find the value also. Then we will go for similarly find dx, or what is your, you can write also as del x also. And what is our dx? Yes dear students, it is the determinant obtained by replacing the coefficients of x, okay, by the right side value, that is d1, b1, c1, d2, b2, c2, d3, b3, c3. You see the coefficients of y and the coefficients of z are there, but the coefficients of x are replaced by the right side value. And similarly we have to find out dy. And what is dy? It is the determinant replacing the coefficients of y by the right side value as a1, d1, c1, a2, d2, c2, a3, d3, and c3. And what is our dz? dz is the determinant containing your coefficients of x and y with right side value, and we have to replace the coefficient of z by the right side value as a1, b1, d1, a2, b2, d2, and a3, b3, d3. Okay dear students, so in this way we can find the dx, dy, and dz. Okay dear students, so initially you have to find what? You have to find d, you have to find dx, you have to find dy, and you have to find dz. Then the procedure says, then it says, or then we can say, then after it, your x is your dx by d, and your y is your dy by d, and your z is your dz by d. Okay, dear students? So this is the way. If you get the value of x, y, z, if you get d, dx, dy, dz, then you can find the value of x, you can find the value of y, also you are able to get the value of z, as x is equal to dx by d, as y is equal to dy by d, and your z is equal to dz by d. Okay, dear students? So this is the procedure involved to get solution of these simultaneous linear equations of three variables. Clear? Now what I hope you learned about the determinant method, about the crammers rule to find out the solution of the variables, that is x, y and z, in two variables and in three variables. Let us move to some examples and check out how the procedure is carried out in our problems. Okay, so let us see it and we will move to the problems. Okay, dear students, so now we'll move to some problems of these type. Okay, so now cleaning this, and with this we are going for some problem solution of this, some problems using those method, that is crammers rule, or you can say by help of determinant. So dear students, let us begin with some questions given as solve. Okay? X plus 3y equal to 0 and it is given as solve two x minus 5y equal to minus 3 and 3x plus 4y equal to, it is given as 7. Okay, dear students, so this is the equations given and we have to find them. Okay, so you see how to get the according to the determinant method, what we have to do, how we can get the value of x, how we can get the value of y, or how we can get the value of our variables. So let us see it, what we have to do. So here it is given, so here we have to find, in the solution way we have to find here our d equal to, it is the determinant containing the coefficient of x and y, that is 2, minus 5, 3 and 4. Okay, dear students, and you can evaluate it also. It is equal to 8 minus 15, so it is 23. Okay, now you have to find out dx. Okay, and what is our dx? You have to replace the coefficient of x by the right side value, that is minus 3, minus 5 and 7, 4. You can see what I did. I replaced the right side value by the coefficient of x, and what is its value? We can calculate it. It is minus 12 minus of minus 35, so it is minus 12 plus 35, that is 23. Okay dear students, now we have to find out dy, and what is our dy? It is the coefficient, it is the determinant obtained by replacing the coefficient of y by the right side value, and it is in this form 2 minus 3 and it is 3 7. Okay dear student, so you can find the value also. It is 14 minus of minus 9, so you can say it is 14 plus 9, that is our 23. Okay, so in this way we are able to get the value of d, we are able to get the value of dx, we are able to get the determinant of y. Okay, so now according to Crammers rule, your x is equal to dx on d, and here dx is our 23 by 23, so the result is equal to 1. Similarly, y is equal to dy on d, which is equal to 23 on 23, so on cancellation it is also 1. Hence the solutions are x equal to 1 and y equal to 1. Okay dear students, so look carefully how we obtain easily the solution of those equations by determinant, by help of determinant, which is known as Crammers rule. Okay, you see carefully. Now we will move to some other question. Okay, look carefully dear students how we obtain the solution. Okay, now we will move to some other questions. So clear? Now we'll move to some other questions of this type of method by using determinant. So I am cleaning this one. So let us begin with another question, that is solve. So you see, now we are going to solve one question, that is solve x minus 2y plus 3z equal to 6 and x plus 4y plus z equal to 12 and x minus 3y plus 2z equal to 1. Okay, so this is given solved. So if you can solve those type of questions, here this you see the system contains three linear equations of three variables, that is x and y and z. Okay, so how to get the solution? What we have to do? First, initially we have to find the value of, by using crammers rule. If we go for determinant procedure, you can find easily the value of x and y and z as per crammers rule. So here we have to find d equal to the determinant containing the coefficient of x, y, z, that is 1, minus 2, 3, 1, 4, 1, 1, minus 3 and 2. Okay, now we can evaluate it also, and we can evaluate d as 1 multiplied by, you can see the procedure, 8 plus 3, and it is minus of minus 2 multiplied by 2 minus 1, again plus 3 multiplied by minus 3 minus 4. Okay, so you can see it is 11, and it is 2 times of 1, and it is 3 times of minus 7. So it is 11 plus 2 minus 21. So it is 13 minus 21. So it is minus 8. Okay, dear student. So we are able to get the value of d. Now we will move to get our dx. What is dx? It is the coefficient of replacing the coefficient of x should be replaced by the right side value, and newly it is this type: 6 minus 2, 3, 12, 4, 1, and it is 1 minus 3, 2. Okay, so we can evaluate it, and we can see it is 6 times of 8 plus 3. It is minus of minus 2 multiplied by 24 minus 1, and it is plus 3 times of minus 36 minus 4. So it is 66. So it is again 46. So and it is your minus 120. So you can see it is our value minus 8. Okay, dear students. So we obtained our dx here. We obtained the value of d also. Now we are moving to get the value of dy. And dy is equal to, we have to replace the coefficient of y by the right side value, and our dy becomes 1, 6, 3, 1, 12, 1, then 1, 1, 2. So you see our value is replaced by the right side value. The coefficient of y is replaced by the right side value, and it is in this form. If you evaluate it, it is 1 times of 24 minus 1 minus 6 times of, it is 2 minus 1, and plus 3 times of, it is 1 minus 12. So it is 23, and it is 1 minus 6, and it is minus 11 into 3, so minus 33. So you see it is your it is minus 16. Okay, so in this way we are obtaining the dy. Okay, dear students, now we will move and we will find out the value of dz. So here dz equal to and Okay, so you see the coefficient of the right side is replaced in form of the coefficient of z of original the determinant d. Okay, and you have that is called as dz. Now we have to find out the value, and what is it? It is 1 times of 4 plus 36, and is minus 2 times of it is 1 minus 12, and it is plus 6 times of it is minus 3 minus 4. So it is 40 plus 2 times of minus 11, and is 6 times of your minus 7. So it is 40 minus 22 minus 42. So you can see it is your minus 24. Okay. So now we obtain the value of d. We have all the results in. Now we have all the results obtained. So we can find the value of x. We have to find the value of y, or we can find the value of z also. So according to Crammers rule, your x is equal to, okay, your y is equal to, so you can find the value of x, and which is equal to, what is the value of x? It is your dx is minus 8 on minus 8, so it is 1, and we can find the value of y, and what is y? It is dy on d, that is it is minus 16 divided by minus 8, so it is your 2, and z is your dz on d, so it is your minus 24 divided on minus 8, so you can see it is your 3. Hence we can get the value of therefore solutions. Therefore solutions are x equals to 1, y equals to 2, and z equals to 3. So you see, and you can verify that this solution is correct or not by putting it there. So you can put and you can check it. 1 minus 4 plus 9. So it is 10 minus 4 is 6. Okay, dear students. So you are now 100% confirmed that yes, this is these results are holds good, and we are able to get the solutions by this type of technique, which is known as Crammers rule. This is very important. Okay, we can solve the simultaneous equations if it is mentioned solved by Crammers rule. Then we can go for this procedure, and we are able to get the value of x with the value of y, the value of z by this technique. Okay. So clear now? Look carefully, and we will move to some more concepts. Okay, so look this one. So what I hope you are now clear about this type of technique to get the value of x, y, z. So now we will move to some more concepts. For this I am now cleaning the board now. So we are going to find the Now we are moving to the concept of consistency and inconsistency of simultaneous linear equations. Okay, so we can say according to solutions of simultaneous, or you can say system of linear equations, it can be categorized as, you see, system of linear equations and if we are going to find those system, so according to this system it is categorized in two parts. One is, you can say, consistent, and another is inconsistent. Okay, dear students? So according to the getting the solutions, consistent means what? Consistent means we are getting solution exists. Solution exists. That means consistent. Solution does not exist. That means inconsistent. Okay? So how we can show or how we can verify that if solution is existing or not? Okay? Now consistent is again it is of two types. Either the solution is unique, or you may get infinite number of solutions. Solution exists means it is of two types. One is unique solution and another is infinite number of solution. So how we can find unique solution is there and how we can find infinite number of solutions are there? Unique solution means, okay, so this is the condition, you see. So it says, now I am going to show you when we are getting unique solution, when we are getting infinite number of solution, and solution means it is no solution exists. So when we are do not getting no solution, okay, that I am going to show you. So we can say I can say with this concept we can start. If the equations are, if the system of linear equations are suppose we will take up three variables are of non-homogeneous category, like a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. So you see here d1, d2, d3, they are non-zero values. All are not simultaneously equal to 0, then it is called as non-homogeneous. Okay? So if it is a non-homogeneous type system of equations are there, then is said to be consistent. Is said to be consistent when? If your d is not equal to 0, if d is not equal to 0, then we can say solution is existing and unique. Okay? And if d equal to 0, which is equal to the dx, it is also equal to 0. dy is also 0. dz is also 0. If all the values are 0, if all the determinants are 0, then solution also exists, means consistent. Okay? But we get infinite number of solutions. We get infinite number of solutions for this type of system of equations. Okay? And said to be inconsistent when? And said to be inconsistent if d equal to 0. Okay, I am writing it on the above, or again I am showing it, and it is said to be inconsistent. When they are said to be inconsistent, for this I am cleaning some portions now. Okay, so now you can able to understand about the consistent or inconsistent. Here I can say inconsistent. When they are said to be inconsistent, if d equal to 0, but at least one of dx, dy, dz is non-zero, then we can say, solution of system of linear equations does not exist, and said to be what? Inconsistent. So this is for a homogeneous, non-homogeneous system like this. Okay? For the non-homogeneous system, we can find the solutions of x, y, z, and or sometimes we can find the number of solutions also. Number of solutions means either the solution is unique, either we get infinite number of solutions, or we don't get any solution. So how we can verify? So what you have to do? The question is sometimes like this: check consistency or not. So how you can check the consistency? So you have to find out the d. You have to find out if d is not equal to 0, then clear that it is consistent and solution is existing and unique. If d is 0, then you can say we have to check out dx, we have to check out dy, and we have to check out dz. If all the determinant values are 0, if all are simultaneously equal to 0, then dear students, we can say that solution is what? Existing, but infinite number of solutions are there. but then they are said to be consistent. So I am noting that one, okay? But if you found that d equal to 0, your initial determinant is 0, the determinant containing x and y and z is 0, but dx, dy, dz, those determinants, out of them one is non-zero, at least one of them is non-zero, then we can say that the system of equations does not have any solution, and so it's said to be what? Said to be inconsistent. Clear, dear students? So this is about the concept of consistency and inconsistency, consistent and inconsistent nature of the system of equations which are under the what type of category? Non-homogeneous category. Clear, dear students? Now we will move to homogeneous category and we will check out. So look carefully this one. Now we will move to homogeneous. Okay, so I am cleaning this one. Next, for homogeneous system of linear equations, a1x plus b1y plus c1z equal to 0, a2x plus b2y plus c2z equal to 0, a3x plus b3y plus c3z equal to 0. Okay, so these are the homogeneous system. Homogeneous system means your right side values all are always equal to 0 in the given system of equations. Okay, and they are said to be consistent, are said to be consistent if d is not equal to 0. If this determinant is not equal to 0, then we can say that there exists a trivial solution, that is x equal to 0, y equal to 0, z equal to 0. Okay, and if d equal to 0, then we say there may exist infinitely many solutions. Okay, dear students, and in both the case is not inconsistent in nature. Either it is consistent, and it is consistent either trivially or non-trivially, means many solutions are there, non-trivial solutions are existing. Okay, so this is the concept on the consistent and inconsistent nature of the system of equations, and from here we are clear that when we get the consistent solutions. Consistent means what? Either we are getting a unique solution, or we get infinite number of solutions, or we does not get no solution. And for homogeneous system also, we see that always it has a consistency either trivially or non-trivially. If it is trivial solution, that is x is 0, y is 0 and z is 0, then the determinant is not equal to 0. And if the determinant is 0, obviously here, dear students, obviously here our dx, dy, dz is always equal to 0. Okay. So if d is not equal to 0, then we can say that there exist infinitely many solutions. This is very important. Okay, dear students, those are non-trivial solutions also. Non-trivial solutions. Okay, dear students. So this is the concept on the number of solutions, and to check out about the concept of consistency and inconsistency nature of the system of equations. With this, we concluded here and we will meet in our next class. Till then, thank you and thank you to everyone.